about the mass weight comment that I left on the Thunderfoot video and some of the controversy. So I made a video about the difference between mass and weight, and I encourage people to watch it if they're going to leave a comment on whatever video about how mass and weight are the same thing. I went through the video explaining why they're not the same thing. So please don't leave a knee-jerk comment, because all of these have been addressed. But anyway, I'm going to address some of the comments that maybe I haven't addressed in full detail, and somewhat briefly, and for people that don't want to watch the 34-minute video. So anyway, here goes. But please watch the video if you want a much more rigorous and clear insight into all this stuff. Okay, yes, but it's not how people measure their weight, which is the point. I don't see the relevance of this, if I'm honest. Most physical quantities aren't measured directly. I mean, if you take the old mercury thermometer, for instance, you're not actually measuring the temperature directly, you're measuring a volume of liquid, which you're converting to a temperature by multiplying by some dimensional quantity. In the same way, of course, you can convert between mass and weight by multiplying by the gravitational field strength, and I've said that explicitly in the video that I made. But there's a fundamental difference between this sort of conversion between two completely different properties by multiplying by a third property, and a conversion between two identical properties by multiplying by some numerical conversion factor. These two things are completely different, and I want to emphasize that because people seem to have been getting the two things confused. The only reason they include pounds is because most of the audience is American, and yeah, you can equate pound mass to kilograms. I mean, this is right, this is perfectly fine. So the only issue I had was that in the context of the video, things might have been a bit confusing because we were talking about freefall, potentially, where the distinction between mass and weight becomes perhaps even harder to understand. So the use of potentially ambiguous units made things, I guess, perhaps more confusing, and it's basically it's not necessarily about the physics being completely semantically right. I mean, in many senses, when a physicist talks about the mass of a proton, they would give it in terms of energy units, and everyone knows what that means. But it still might be confusing to the people that are learning physics when sort of slack terminology like this is used. It's an interesting point for those that are learning this sort of stuff, and I don't want to get too hung up with the semantics, but I still think it's important to make things as clear as possible when you're learning this sort of stuff. So it starts off with a quote, and then it goes, "You can weigh mass. Did I just discover something new in the line of scientific field, or did I just point out something you didn't know?" Well, I know what he's trying to say. You can weigh an object, you can weigh matter. But you can't weigh mass, because mass is a property. Saying you can weigh mass is like saying you can weigh temperature, or you can weigh speed, or you can weigh distance, or you can measure the acceleration of speed. You can... Weight is a property of a system, mass is a property of the system. They are related to each other, but the fact that they're related to each other does not mean that you can weigh a property. That doesn't even make any sense. I mean, distance and speed are related to each other. I mean, one's derivative of the other, but it doesn't mean you can measure the speed of distance. It's meaningless. So in a strict sense, this is wrong. So, okay, I think that's addressed. So I'm going to replace all the expletive just to make this video more watchable. Quantum, you screwed up on so many levels, it's not even worth getting into. But above all, your failed attempt at pedantry, if it were accurate, it would probably qualify as the most pointless conversation I have ever counted, and I once stumbled on a comic book forum. Okay, so this is I guess one of the common objections about this, that it's a semantic and pointless argument to be having. Okay, so I have a few points about this. Firstly, it seems completely hypocritical because there was various other comments about calling Thunderfoot out on the difference between the two words lose, L-O-S-E, and lose, L-O-O-S-E. I mean, that quantifies more as semantic pedantry to me than this does. So I don't really understand why there wasn't an uproar about that. But, okay, Secondly, yes, in some respects it is pedantry, but most comments on these sorts of videos are pointless anyway. They don't have any purpose. Most are just satire. So in terms of utility, most have basically no utility anyway. But this all changed before I made the video on mass versus weight. And I think that this does have utility now. And the reason is because so many people in the comments made some very simple and fundamental physics mistakes. So I think this has gone from being a sort of offhand, interesting little, I call it, tidbit of information, which is fine. It's no more useless than a satirical comment, to something that is useful in correcting some fundamental misunderstandings about the physics. Okay, so this comment makes the point about the fact that the force pound and the mass pound exist, and the countries use different systems, which is fine. But I want to illustrate that the whole point about all this is that when you're learning something like physics, you want to have an unambiguous system to learn by, to stop yourself from being confused. And this applies to anyone that's trying to learn anything, really. By the time you're a scientist, it doesn't matter because you already understand all the nuances. Just like someone learning the English language understands about all the verb exceptions that someone who is being introduced to the language might not understand. So, for those that are learning science, it's important to have a system that is as concise, lucid, clear, and unambiguous as possible. And that's the whole point of all this. So the fact that you had to specify you were talking about force or mass anyway sort of just validates my point. We should be doing that, and we should be using the metric system anyway, because that is the unambiguous system. Okay, so let's take another example of ambiguous units. Let's look at the calorie, which is very ambiguous. There's the food calorie, there's a thermodynamic calorie, for instance, and there's a factor of about 1,000 difference between the two. And that can be confusing. Whereas the joule is unambiguously defined as a unit of energy. And this is a far better way of learning. This one is probably better to look at the 34-minute video, because I addressed these sorts of comments by looking at all the equations and just working it through. So I would advise people did that. I put up a contents page as well. So very briefly, first there is a mass-to-mass ratio that determines weight. Well, we know that a mass-to-mass ratio can't possibly be a weight because the dimensions are not equivalent. A mass divided by mass is a dimensionless number, and a weight is a vector quantity with a unit. So we know that that's wrong. But I'll give you the benefit of the doubt because you say determines. You don't actually say that they're the same thing. Your mass in relation to the Earth determines your weight. Well, it partly determines it. It's based on a load of other factors as well. So to imply that it exclusively determines it, okay, I'm not sure if you are implying that, but if you are, it's wrong. I.e. mass-to-mass ratio that determines your weight. No. Okay, so the simplest definition of weight, and the one I'm going to use here, weight is equal to the mass times the acceleration due to gravity. Okay, so the acceleration due to gravity is proportional to the mass of the Earth. So note that your weight is proportional to your own mass, and it's also proportional to the mass of the Earth. In terms of Newton's law of gravitation, we have a product, that the force between two bodies is equal to the mass of one body multiplied by the mass of the other body, divided by the sum of the. By saying it is a result of gravitational field strength, you ignore that gravity is determined by the pull one mass has on the other. No, I'm not. Gravitational field strength is the acceleration due to gravity. G is a function of the mass of the object causing the gravitational field and the distance you are from the gravitational field. I went through this in far more detail in my video, but no, this is completely wrong. Gravity does not exist on its own, which is what you're implying with this statement. No, I'm not implying it with this statement, and this is why you don't argue physics with this meaningless verbal silage. You actually look at what the equations say. This is why we use mathematics. It's a much more coherent way of arguing this sort of thing. So I please advise people to look at this, the mass equivalence principle section in my video where I go through all this sort of thing. But no, that's completely wrong. Another quote, "Oh really, I weigh 75 kilograms, so you're wrong about that." No, you don't weigh 75 kilograms, your mass is 75 kilograms. Okay, and some more quotes. How much mass you have is directly related to how much you weigh while you are on planet Earth. Yeah, that's fine. The two quantities, mass and weight, are directly related. I've never disagreed with that point. If I have X mass and you have X mass while on Earth, we both have 75 kilograms. If X mass equals 75 kilograms, I don't really see the point of that. What are you saying? This just seems to be a pointless tautology. If I have 75 kilograms, if my mass is 75 kilograms, then it is 75 kilograms. This is just a tautology. What are you even trying to say here? If you are on another planet, your mass will be different. No, it will not be different. If your mass is 75 kilograms on Earth, it is 75 kilograms everywhere in the damn universe. It doesn't change. Unless you take into account all relativistic effects and approaching the speed of light, that sort of thing, which clearly were not in this context. So again, on Earth, mass and weight are the same. No, they're not. They're not the same. And this sort of exemplifies this point. One is a force, one is an extensive property. That doesn't depend on where you are. I have a hard time believing you actually understand the things you are saying. If you did, I doubt you will be wasting your time like this. You are most likely Googling irony, isn't it? And parroting it. You are unable to grasp the basics or extremely hung up on semantics. Well, I covered the semantics thing. This comment is exactly why. This whole thing is not just semantics. Okay. You admit in the thread you knew was talking about personal weight measurement. No, I think he was talking about mass, actually. Especially since when you lose mass, your weight decreases. They're proportional, they're not the same, and that's the mistake loads of people were making. I'd like to point out a distinction you made later. You have not gone back and reflected on your original comment. Okay, I did actually go back and reflect it now, after this comment was written. There exist two uses of pound mass and pound force, that's fine. My engineering fundamentals distinction has been shown to be important. Okay, and I would agree with that. And while your Mars rover has crashed because of confusion, such the engineers should have known better. Well, you answer your own point there. You say that it's important, and this is the reason why. Well, a justification anyway. If people want to think I'm showing off, then whatever. I think the more important thing is that people are making these basic physics errors shamelessly, and would rather dig themselves into a hole doing that than simply admit that they don't understand the physics behind what's going on. I only made these videos because of the physics misconceptions. I didn't make them because of some trivial semantic reason. But yes, I made the oversight. I made the oversight that the other word opposes pound is used more pervasively than it is, and I don't see why I'm penalised for simply acknowledging a mistake I made. Surely admitting when you're wrong is a good thing. To be clear, I wasn't being dishonest about that. It was a genuine oversight, and I apologise for that. But the general point still stands. We should be using the metric system anyway because it's unambiguous. And like I say, in the context of the video that Thunderfoot was making, there is still a potential confusion between the mass and the weight. So there we go. I didn't call anyone dumb. I don't know where this has come from. Given some of the comments that I've received, I think I've been very civilised in light of the vitriol that I've received. People have been saying things that are wrong. I've been telling them that they're wrong. That's basically as far as it goes. Anyway, let's leave it at that. This comment is basically correct, so I'll read this anyway. You think values were in lbm, although 1 kilogram is about that many lbm. Mass and weight aren't the same property, but gravity is constant, so they have a linear relationship. You literally multiply or divide one by a constant to find the other. Mass and weight are easily switchable because you always know gravity. So I'm going to bring up one point, and this person didn't make it, but a lot of people have been saying that because gravity is constant, mass and weight are the same thing. I know this person didn't say it, but this is not true. The fact that gravity is constant is not really that important in all of this. Even if it is, then it doesn't mean that mass and weight are the same thing, and I've tried to address why. You know, they're two completely different things. Now, gravity is a constant in a sense. When you're on the surface of the Earth, it doesn't change much. It still has a unit. It's still an acceleration. When you say gravity, you're talking about acceleration due to gravity. Just to say gravity is ambiguous. Are you talking about a gravitational mass? What are you talking about? You actually, in this case, you're talking about an acceleration due to gravity or gravitational field strength. And yes, it is constant near the surface of the Earth because the distance that you're falling is going to be small compared to the radius of the Earth. So, when you look at the inverse square law, r really doesn't change that much. So because r doesn't change that much, it's only a function of the mass of the Earth, and the mass of the Earth doesn't change that much either, so it's basically a constant. But it's still an acceleration, and this is a very important point. And please note that it's only constant when you're not moving through a large distance. It's constant near the surface of the Earth because you're not moving a very large distance. And to illustrate, it does vary somewhat. I mean, it's slightly different because of the way the Earth rotates. It's actually slightly different on the equator than it is on the pole. So, on the equator, it's about 9.78 meters per second, and on the pole, it's about 9.83 meters per second. So there is a slight variance, and actually, this variance is important because for things like calibration, you have to take this into account. Your location on Earth. So the value of g does vary, and this variance is important if you want exact measurements in some cases. But please note, the point of all this is that you still have to multiply by g to get from mass to weight. You can't omit this. This is very important, and please note that g is an acceleration which is a function of the mass of the Earth and the distance you are from the centre of the Earth, which to all intents and purposes is nearly constant when you're falling through relatively small distances. Interesting video, even though you didn't watch it, but you clearly screwed up in those comments and didn't realise it. You edited most of your comments to sound right, and changed your opinion multiple times. I edited my comments to make things clearer or add more information. I resent the accusation of dishonesty here. I told you to calculate weight. I told you how to calculate weight. Very simple. Right algorithm, wrong parameters. Oh God. And I get accused of using too much jargon. But only because I was making it simple for you. Because I thought you were simple. You were proved wrong by 50 people. You get mad and you make a video about it. Weight and mass are the same on Earth due to the same parameters. Yes, mass and weight are not the same thing. Thunderfoot probably meant mass, but he was using them interchangeably in a colloquial sense, which is fine. Certainly if you know and understand this stuff, and physicists do things like that. They talk about the mass of a subatomic particle when they mean the energy. But that's fine, because they understand what they're talking about. It's interchangeable. They don't have to be 100% rigorous. But if you're learning the stuff and you don't understand it, then you can get yourself so easily confused like this. So, I'm sure no one would condone using this sort of nonsense physics in order to try and prove a point that you're technically speaking wrong about.